Hello and welcome to PE Academy. So in this video, we're going to be looking at the concept of gradient of a function, and for short, they call it grad. Okay. So before we get into this video, please, if you are new here, or you are yet to subscribe to the channel, can you take our time to click on that subscribe button? You'll find it somewhere at the lower right of your screen. So go ahead and click on that subscribe to the channel. Alright, so thank you very much if you have just done that. So now let's get into gradient of a function. So when you are dealing with grad, so it's just from three concepts. We have the gradient, the divergence, and the curl. Exactly. So now we are dealing with gradient. For curl and divergence, we are going to be looking at that in a separate video. So for the gradient, if I should call gradient of a function or grad, we are still saying the same thing. So for short, they call it grad. Exactly. Now, it has a sign, or it is represented like this, an inverted delta sign. Some can have an arrow at the top and some might not have an arrow, but once you come across something like this, just know that we are dealing with grad. So mathematically it is expressed as this grad. Now also let me just mention that this symbol or sign is called nabla or del. Exactly. So any of the two, you can use it. That's what that symbol is called. So mathematically it is expressed as partial differential, that's towards the I coordinates, plus partial differential of y towards the j coordinates, plus partial differential of z towards the k coordinates. Alright, so you also have to take note of this, that with what you are seeing right now on your screen, where I have this sign like this, is different from d over dx. Exactly. So this that we're having here is for partial differential. It's for partial differential. Why this is for just differential. If you have to differentiate an equation, or when you're asked to differentiate, you write it like this. But when you are dealing with partial differential, this is for partial differential. Exactly. So that is what we are making reference to under this topic. So they are a little different. Exactly. So you have to take note of that. So what I want us to do now is, okay, before we take an example, so let's say if we have a function, like let's say we have a function of phi, and it's having the x, y, and z coordinates. Exactly. And we are asked to look for the grad. So the grad will be looking like this. So that means we're going to be having, exactly. So that's the grad of phi. Let's say grad of phi is the function. So what we are going to be having is the partial differential of the grad plus partial differential of the grad to the y, and j plus z towards the k coordinate. So this is the formula that you are going to use if you are to do this. Exactly. Alright, so once we look at an example, you are going to understand it better. Alright, so now let's look at one example. Let me call this example 1. Alright, so let's say we have a function like this. Let's say we are given that phi is equals to x squared y z cubed plus xy squared z squared. Exactly. And then we are asked to determine the grad phi at points P, where P is 1, 3, and 2. So what this simply means is that now the question can decide to just stop here. You can decide to just stop here that a function phi is equals to this, which is x squared y z cubed plus x y squared z squared, and you are asked to just determine the grad. So but this one went further, says to say that at points P is 1, 3, and 2. So what this means is this is for x, y, and z. Don't worry, we are still going to get there. Exactly. Alright, so now let's go ahead and solve this question. So let's do the solution to this. Alright, so now let's recall that. So for this, that is the formula we are going to apply since we are dealing with grad. So we are going to be having grad of phi is equals to, so just what we have at just what we have at the top, sorry. So that will be partial differential of phi of x plus partial differential of phi of j plus over z and k. So now let's put in the values. Now recall that from the question we are given that this is the value for our file. So now let's do the first one, which is the partial differential of phi to partial differential of x. So for this now, what this actually means, this that we are having here is, if you look at this function, exactly, if you look at this function that we're having here, we are going to differentiate it with respect to x. Exactly. So that means it's only x, the one that is having x, that we are going to differentiate. The ones that are not x, we are going to take them as a constant. So the one I circled in purple, we are going to regard them as a constant. Exactly. So that's the difference between the partial differential and then the full differential. So let's quickly do this. So if you have to look for the partial differential of the function with respect to x, we are going to be having, so for x we are going to be having 2x, then with the y, this y and the z cube will be taken as a constant, so we are going to write it back. So we're going to be having y z cube plus, now for this we are having x, this x, if you should differentiate x, is going to give us 1, then this will be a constant, so we are going to be having y square z square. We don't need to write 1 because it won't make any significant difference, so we can just decide to skip that. I hope that's clear. So now let's do for that of y, so over partial differential of y. So now let's look at the function again. So this now, if I should differentiate this with respect to y, so we are going to be having x squared, this y, if you should differentiate y, you are going to have 1. So then this x squared and then z cube will be taken as a constant, so that will remain. So we are going to be having x squared z cube, so let me write that, x squared z cube plus, so now let's differentiate what we have here. So if we should differentiate y squared, we are going to be having 2y, then the x and the z square will remain as a constant, so we are going to be having 2x y z square. Exactly. So 2x y z square. Alright, so that is for the y. So now let's go ahead and do that of z. So we'll be having a partial differential of with respect to z. So now let's look at it together. So again, if you have to differentiate this with respect to z, so you are going to be having, if you should differentiate z cube, that will give us 3z squared. Now this x squared and y to remain as a constant, so we are going to rewrite that. So this will give us 3x squared yz squared. Exactly. So now let's write it. So 3x squared yz squared plus, so now let's do this. So this will give us, if you should differentiate z squared, that's going to give us 2z. Now this x and y square will remain constant, so that will be, we'll rewrite that. So that will give us 2x y square z. Exactly. Now, so next thing we have to do now, since the question says at point P, where P is 1, 3, and 2. So now let me just do this on the side here. So we are told that when the P is 1, 3, 2. 1, 3, 2. Are we good? So what this means is that our x is equals to 1, our y is equals to 3, and our z is equals to 2. Are we good? So what we are going to do is we are going to put in the value of x, y, and z into what we are having here. Are we good? So now let's start with this. So for this now, if you should put the value of x, y, and z, that means our partial differential of phi with respect to dx will be given as, so now if we have 2, so we're going to be having 2 times our x is 1 times our y is 3 times our z cube, which is 2 raised to power 3, it will be 8. So let's punch that in the calculator. So we're having 2 times 1 times 3 times 8, and that will give us 48. So we'll be having 48 plus, so for this now, y square z square. So y square is 9, that's 3 squared, that will be 9 times z square will be 4. So that will give us 36. Very good. So 48 plus 36, that will give us 84. So we are done with that. So now let's go to this. So partial differential of phi, partial differential of y. So we're having x square z square. So let's put in the values. So x squared is 1 times z squared, that's 2 raised to power 2. That will be 4. And then plus, this will be 2 times our x is 1 times our y is 3 times our z squared, that will be 4. So this will give us 4 plus 2 times 1, 2 times 1 times 3 times 4. So that will give us 24. So the total of this is 24 plus 24. And that will give us 24 plus, okay, so just a little correction, this should be z cube. So that should be z cube. So let me correct that. And so this will be 8. So let's just check it together. So if you have to differentiate this with respect to y, so that means if you are differentiate with respect to y, so differentiation, if you differentiate y, that will just give us 1. So we'll be left with x squared and z cube. So x squared and z cube. So that means this will be 8, not 4. So 24 plus 8, and then that will give us 32. Okay, so let's do this. So partial differential of 5 over partial differential of z. Alright, so for this now we are having 3 times x squared is, our x squared will be 1 times our y. Okay, so our y is 3, so times 3 times, then our z squared will be 4. So plus 2 times our x is 1 times 1 times our y squared will be 9 times our z is 2. So let's put this together. So we'll be having 3 times 1 times 3 times 4, and that should give us 36 plus 2 times 1 times 9 times 2 plus 36, and that will give us 72. Are we good? Alright, so now let's compute. Now our final answer will be looking like this. So we're going to be having our grad file, which is same as writing it with the symbol or the sign. Grad file is equals to, so let's see the first value, 84. So that will be 84i plus 32j plus 72k. And this is our final answer. Exactly. So this is what our final answer will look like. So it's also important to mention that once you are done with your calculation, don't forget your the coordinate, the I, the J, and then the K. Exactly. So in some questions that you might come across after your calculation, you might not, maybe let's say for example, the value of your J is 0, so you'll be having something like 84I plus 0J. So once it's like that, you can decide to just omit it and have 84I plus 72K. Exactly. So it's not in all cases. But however, don't forget the IJK, because let's go back to the formula real quick. So let me make that clear. So you see that after you have done the partial differentiation, we are still having your I, your J, and your K. So why I'm saying this is that this is one significant difference between your calculation on grad and when you get to div. So once we get to div, you understand what I'm saying. All right. So now let's look at another example. So all right. So I'll be doing the second example. This is example 1. I'll be doing the example 2 in another video. That'll be in the next video. I don't want this video to be too long. So that's it, guys. I hope you find value. If you have any question, do leave them in the comment section below, and then I'll see you all in the next example. Thank you.